Okay, now we're looking at lesson 5-5, which is the differences of two squares, and that's on page 204 in our textbook. So the difference of two squares. I'd like to start out using some pictures that we have, and from the pictures we can start to work out deriving the formula. So we'll draw a square over here. You can see it's perfectly drawn there. Okay, so we'll use your imagination, and this is a square, and each of the sides of the square is A. Now what we're going to do is over on the left side here, add in a rectangle which we're going to have B as its side. And then up at the top, we're going to take the same size as this rectangle up at the top and draw a line there so that this width here is the same width as down here. They're both B's. And then this area here is A minus B. So the sum of these two segments here would be A, one being A minus B and the other one being B. And then over here vertically, we have A and plus B. So when we look at the differences of two squares, we have an A plus B over here and an A minus B up here. So this rectangle is a factor of A minus B for its area. And at the bottom, this one is B factor of A minus B for its area, all right? So visually there we can see the area of these two rectangles, one being A factor of A minus B, the other being B factor of A minus B. So we add those two areas together, we would have A factor of A minus B plus this area down here, B factor of A minus B. Okay. Now we have two common factors here, A minus B. So let's factor that out to the right side. So we're going to factor out the A minus B, and what will be left over here will be A plus B. Okay? So what we have left is A plus B. Right? And these then are what we term the differences of two squares. Now the learning objective in 5-5 is to simplify products of the form. So our objective is, okay, at the end, the student will be able to simplify products of the form A plus B and A minus B. So that's the first objective that we have. And the second objective is to factor differences of two squares. And to factor differences of two squares. Okay, so that's our learning objective that we have initially here. If we look at the summary block in the center, it has A plus B factor of a minus b is equal to a squared minus b squared. So that's the summary equation they have here. The sum of two numbers times their difference is equal to the first number squared minus the second number squared. Well, let's take a look at that. And we can look at example number 1. So example 1, and remember, for the most part, the examples are really looking at, they're like the sub-objectives for the main objective. If we get to understand the 3 or 4 examples that we have, we'll get to understand the overall objective. So the first one, actually example 1 and example 2 are both the same. They say write each product as a binomial. So example 1 has x plus 3 and x minus 3, and we want to write it as a binomial. And we remember binomial just basically means 2 terms. Okay, we're going to have 2 terms in it. So let's try this with the FOIL method, and we can do the first terms. That would be our x squared, and our last terms, that would be a minus 3x, and our inner terms, inner, which would be a plus 3x, and then I'm trying to make something smile, and it's not smiling for me. So x plus 3 times x minus 3. And we're using FOIL. So first, outer, inner, and last. So let's look at this. If we're going to get the last terms, that should be able to give us the bottom part. So that'd be a minus 3x. If we look at the inner terms here, that's going to give us the plus 3x. That's the inner. And then we're going to look at the first terms. That's our x squared. And our last terms, that's going to be our minus 9. So it's not as nice
It looks great.
little eyes, and there's the ears, and this poor fella doesn't have much of a forehead, but has a big chin.
No
Probably
hair.
like I was thinking of one of the Tonight Show guys. That's basically, when we get to this point now, we notice that when we combine like terms, we have a minus 3x and a plus 3x, and that's going to cancel out. So this will become x squared minus 9. So that's example 1, and that's basically showing us the way of doing the a plus b times a minus b is equal to a squared minus b squared. And here's FOIL, and we're getting that. Here's when we have our x plus 3, x minus 3, this is the a, and these are the b's. So a plus b times a minus b is going to be our a squared minus our b squared if we just went and used that equation that's given to us for the difference of 2 squares. Now if you look at example 2, it's basically the same. It says write each product as a binomial. The only difference that we have in that is that they're more complex. So if we look at example 2a, it has a squared minus 2b. So we have a squared minus 2b and a squared plus 2b. Now, if you're into that point where you just want to apply the formulas, change these a squared minus 2b, a squared plus 2b, so we don't get confused with the equation that they have us working with. Let's make these C and D. So we're changing example 2 to be C squared minus 2D and C squared plus 2D. And that's so when I say that this is the A and this is the B, we're not showing A to A and an A to a B there. Now it looks complex, so it should be example 2 is A squared minus 2B. Okay, but when we look at this, if we go to if this is my A, that's my A's, then its square of that is going to be C to the 4th power. Okay, C squared times C squared is going to be C to the 4th power. And then if this is my B term, when I square that, well, the integer 2 is going to be squared to be 4, and D is going to be squared, and that's a minus sign. So we could look at the problem and quickly derive its answer, even though it's more complex than the first problem. Okay, so that's basically applying that equation they have there with A plus B, factor of A minus B, is going to be equal to A squared minus B squared. If we move into the second part of the objective, which is to factor differences of two squares, so now we're looking at the second part, factoring differences of two squares. And let's look at our first example that we have there. X squared minus 49. So x squared minus 49. And that's example 3a. They have z squared. So it's example 3a on page 205. And I'll make that a z. Okay. Now, if we looked at this and didn't just go and say reverse the equation that we had, and we applied your AC method to that, we would expand this to be z squared plus 0z minus 49. And then we're going to form a table here where this is the multiplication and this would be the addition. Right. And now let's look at the products. 1 times a minus 49 would be a minus 49, and the sum is in the middle here, and that's 0. And now let's look in terms of what two numbers, when we multiply them together, will give us 49, and we sum them, will give us 0. Well, that would appear to be a minus 7 and a plus 7. When I product them, it would be a minus 49. When I sum them, it's going to be 0. And now let's look at the coefficient for the z term here is a 1. So this is then going to come out to be x minus 7 factor of x plus 7. So if we did it through the AC method, that's what we would come out with. If we just applied the a squared, if we apply the a squared minus b squared equals a plus b factor of a minus b. You might say just in one step we could see that this is going to be, this should be z's. In one step we could see that this is going to come out to be the z minus 7 and z plus 7. In other words, what the square root of 49, perfect squared, would be a 7 plus or minus 7. All right, so that's looking at example 3, where we're trying to factor differences of 2 squared. Now let's jump down to example 4. And example 4 is a lot more complex, but it will work out in the AC method, and then you'll see how simple it is when you just apply the a squared minus b squared equals a plus b factor of a minus b. So let's look at 16r to the 4th, 16r to the 4th, minus 625. And this is example 4. Example 4. There's no B with example 4. That is just example 4. Now let's look in terms of solving the AC. So this would come out to be 16r to the 4th plus 0r squared minus 625. If we look at the product or the multiplication, the sum or the addition, then we would have 16 times a minus 625, and the sum is going to be 0. Now, I must admit that I did not do this mentally. I went and put it into a calculator, and when I did, it came out to be a minus 10,000. Minus 10,000. Okay, so when I think of that, what two numbers multiplied together are going to give me a minus 10,000, and whose sum is 0. I can see that it's going to be a plus 100 and a minus 100. That'll give me the 10,000, and their sum is going to be 0. Now I look at the coefficient here, for r to the 4th, and that's 16. So I put that underneath both of these. So I'm ending up then with 100 over 16 and minus 100 over 16. I'm going to simplify them. So what's the greatest common factor between 16 and 100? And it looks like it would probably be a 4. So 4 goes into 16 4 times. 4 goes into 125 times. Here we have 4 goes into 4 times, and then 4 goes into a minus 100, minus 25 times. So now with that AC method, I come out with 4. Let me make sure I'm using the proper letters. 4 squared plus 25 and 4r squared minus 25. So the AC method works very well there. But if suppose we come up here and say, well, what if I just applied a squared minus b squared equals a plus b factor of a minus b, I would see that if this is my a squared here, that's a square, this is a square, so my a is actually going to be the square root of that to be a 4x r squared, say plus square root of 625, 25, and then repeating that as 4r squared minus 25. So basically, when you apply the equation a squared minus b squared equals a plus b times a minus b, the difference of two squares, you can quickly come to the solution of it. And that might then beg the question, well, what happens if you had a plus b factor of a plus b? Now that's not the difference of two squares, and that's not in this lesson, but that's going to be in the next lesson.